Hello friends, welcome to my channel. Let's have a look at problem 2343 together. Query Kth Smallest Trimmed Number. In this video, we're going to share a solution based on Radix sort, also known as digital sort. So this problem requires to return an array called answer of the same length as the queries given in the problem statement, where answer I is the answer to the S query. For the S query, we need to trim each number in nums to its rightmost trim I digits, and then determine the index of the Kth smallest trimmed number in nums. So here are two examples. We are not going into details for these two examples, and after we analyze this problem, we're going to give a walkthrough for example 1. So next, let's look at the constraints about this problem. So the nums array has length bounded above by 100, and each number in the nums array also bounded above by 100 in length. So if we examine these two numbers, both 100, so actually for this problem, we can use a brute force solution. So with that said, let's look at the method here. We're going to build a solution based on Radix sort or digital sort. So the idea is the following. We're going to do organizing according to each digit of a num from the least significant digit to the most significant digit. So the procedure is as follows. So we have in total 10 digits, right? 0, 1, up to 9. Then we're going to use 10 buckets and assume that each number has length d in nums. Then, for each of the d digits, we linearly traverse the nums from previous step, and then put the number in the corresponding bucket, and then we build the nums array state by joining the buckets in order. So in this problem, due to the requirement of the return, we shall track the index of nums of the numbers in the original nums array. So with that said, let's look at a walkthrough for example 1. So here are the nums and queries. So in the process, we're going to append each number with the corresponding index in the original nums array. So if we first consider the rightmost digit, then this one is going to put into bucket 2, and this one going to put into bucket 3, and this to bucket 1, this to bucket 4. And then if we flatten the array according to the bucket order. So this is the state after we do the flattening operation. So this is in bucket 1, this is in bucket 2, this is in bucket 3, and this is in bucket 4. After that, if we do the organization based on the second to last digit, so this one is going to put in bucket 5, this going to be in bucket 0, and this in bucket 7, and this in bucket 1. Then if we joined the buckets according to the bucket order, then this is the result, right? So this is bucket 0, this is bucket 1, this is bucket 5, and this is bucket 7. And then we are going to do the organization based on the leftmost digit. So for example, this one is in bucket 1, this one is in bucket 8, this one is in bucket 2, and this one is in bucket 4. And then if we flatten the array and join them together according to the bucket name or bucket order, so this is bucket 1, bucket 2, bucket 4, and bucket 8. So after this three process or iterations, we achieved the requirement for this problem. So notice that in the process, we have remained the index for each of the number in the original nums array. So in order to get the corresponding index for each of the query, for example, 2, 3, then we are going to check the third row above. So here is the third row, and then we are going to check the second element corresponding to index 1, right? So the second component is the corresponding index for the second smallest number. So here is 2 for this query. So with this pattern, we can get all the corresponding index for queries in the queries list. So with that said, let's look at the code. So first, I'm going to write a Radix sort hyperfunction. So this hyperfunction accepts 2 additional arguments. One is array and one is position. The array is a list of tuples of the form num and idx, the index. The reason is for this problem, we're going to track the index. So the position is the digit position according to which we're going to organize the buckets and put the number into the corresponding buckets. So with that said, let's do the real work. Let's first put numbers in the bucket, corresponding buckets. So let's first initialize the bucket. So bucket equals I. As initially it's an empty list for I in this 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the initialization. Then we're going to do a linear scan for the array for item in array. Then we're going to put the corresponding number in the bucket. So item 0. So this is the number, and the digit we're going to use to determine the bucket position is position, right? So then we're going to append this number. So this item. So notice that the item is a tuple which consists of 2 parts. One is the number itself, one is the corresponding index in the original nums. So that's the step. This step. Next, we're going to flatten and obtain new state. So for this, I'm going to initialize an empty array, and then we're going to traverse the bucket. So for bucket in this, then we're going to extend the result by the current element in the corresponding bucket. So that is buckets bucket. So also you can maybe do something like this, bucket name or bucket name. So this is more suggestive. Then we're going to return the result. So this is the main hyperfunction we're going to use. So now let's look at the main logic for this problem. First, I'm going to check how many digits in each of the number. So that is length nums 0. And then we're going to initialize a lookup table. So initially an empty array. So you can think of this three lines. So then the base we are going to use to iterate is this. So for n and I, for I and n in enumerate nums. So this way we're going to be able to track the index for each number in the original nums array. Then we're going to use this base as an argument in the Radix sort function. So with that said, let's do the Radix sort according to each digit successively. According to each digit successively. Then I'm going to iterate from the least significant digit to the most significant digit. So for I in range d-1, -1, so we're ending at position 0. And then the temp variable is going to the state after we organize according to the ith digit. So that is the Radix sort. So the base and the ith position. So afterwards, we're going to append the current state to the lookup table. And then we're going to reset the base to be the current state. So that's about the process as we do the walkthrough above. And after this, we're going to prepare the output. So for this, we're going to initialize a result variable, and then we're going to scan for each of the queries. So for query in queries, then we're going to append the result for this query to result variable. So we're going to look up from the corresponding row and corresponding column. So the row is actually Q1 minus 1. So for example, here is 3. So we're going to check the row with index 3 minus 1, that is 2. And then we're going to check Q0 minus 1. For example, second smallest corresponding to index 1. So this is the item we're going to check. And then we're going to track the second element in the item we got. So that's the whole procedure. So finally, we can return the result. So that's the full solution for this problem. So the main structure is that we implemented a Radix sort hyperfunction, and then we, in the main function, after we do the reorganizations of numbers, and then we are going to track the result according to a lookup table. So with that said, let's do a special case check. Yeah, it passes the special case, and then we're going to do a generic case check. Yeah, it passes the generic case. I would say for this problem, this is one format of solution using the Radix sort or the digital sorts. So due to the constraint that in this problem, actually we can just do it in a brute force way. It's still okay. Thank you very much.